Today we will continue with a simple fact regarding electric field lines due to different charges. You can see I have drawn X. X is an unknown charge, and already I told you that a test charge is always a unit positive charge. So I am going to place a unit positive charge in its surrounding. Now suppose if we see that this test charge is getting repelled, whether I will place it over here or over here, and it is getting repelled from X, then as we already know that X like charges repel, so the probability is that X is a plus Q charge and this test charge is feeling repelled or it is moving away. So the field lines will be like this. Now you can see the situation. Mind you, while drawing these field lines, I have drawn this outward because this test charge will move outward, because the test charge is always a unit positive charge and this X is supposed to be plus Q. You can draw as many field lines as possible, and the interesting point regarding these field lines is that when they are near to the charges, their concentration increases and they are very close to each other, and when we will move away from the charge, then the distance between field lines increases. So always keep this in mind. Concentration of the field lines shows that the strength of the electric field has increased. Now assume another situation. Again I have taken a charge as X, and suppose that a test charge is feeling attracted towards this charge. So the possibility as for the concept is concerned that this X might be a negative charge, because unlike charge attract each other, and there is no doubt that test charge is always a positive charge. Test charge is always a positive charge. So you can see the situation that if this X is minus Q or a negative charge, then the test charge will get attracted and the fielded lines corresponding to this minus Q will be acting towards the charge. Previously we have drawn a situation where the field lines are moving away, and here the field lines are moving towards the negative charge. Now again presume a situation where there are two charges, A and B, and the test charge is feeling attracted towards both of the charges. So certainly they are negative charges, but it can be attracted towards this, or that depends upon the nearness to this charge. If suppose this test charge in between, then because of the equilibrium of force, and if the magnitude of A and B is also same, then the possibility it won't get attracted towards any of these charges. Then the field lines would be like so. As I was saying that these charges, if they are negative and this is the test charge, neither of them will attract them if their magnitude is also same, but the field lines will move or look like this, because both of them are trying to attract the test charge. Similarly, if the pair of charges are positive and are of equal magnitude, then test charge will feel repulsion, and if it is in near middle of these two charges, then either it will get repelled by both the charges If it will lie somewhere over here, then it will feel repulsion, or if it will lie over here, then it will feel repulsion. So based on that, I have drawn the field line. You can see that they are moving outward, and because both of them are positive, so in between their influence is getting cancelled out and there is no field line in between. Or you can say in between there will be a situation where the influence of both these charges will add up here. Now assume a situation where there is a pair of charges having equal magnitude, but the polarity is just opposite, positive and negative. From positive the field lines are coming out, and for negative it is coming in. If such pair is there, and that is known as electric dipole. And suppose I have placed the test charge over here, then it will feel repulsion from positive charge and it will feel attraction towards negative charge. Hence the field lines are coming out of this, whereas it is moving towards negative charge. Hope you have understood the concept and you will revise the field lines regularly. Thank you.